Welcome. In this video, we will take a look at some foundational properties of derivatives. The first property of derivatives we'll take a look at is that the derivative with respect to x, this is what this notation d dx is meaning. This is stated the derivative of here c with respect to x. That's the variable of differentiation. This, if c is a constant, is just going to be 0. The derivative with respect to any constant is equal to 0. To highlight why that is true, we can consider a constant function. Any constant function we can write as a horizontal line. Call this f of x. And the derivative of this horizontal line we know is 0 at all points. So the rate of change of any horizontal line we would say is 0. So any derivative of a constant will be equal to 0. A second property we can take a look at is the derivative with respect to x of a constant times a function of x will just be that constant times the derivative of the function of x. So this is called our constant multiplier. Rule. So whenever we have a constant multiplier, it will survive in the derivative, and we'll take the derivative with respect to the x function involved. The third property on our list is the power rule. This power rule tells us that if we have a function x to the n power, where n again is another constant number, that the derivative with respect to x of that power function is going to be n times x raised to the n minus 1 power. So there's two kind of operations we do with the power rule. One is bring down the original power. Second, we subtract the initial power on x by 1. That's called our power rule. And then the last rule that we can take a look at, number 4, the derivative with respect to x of a function f of x plus or minus g of x is the derivative of each individual function added or subtracted together. So this tells us that the derivative operation can be passed and distributed through addition and subtraction. So in other words, we could write this in D notation as well. The derivative with respect to x of f of x plus or minus the derivative with respect to x of the g of x function. So when we have a function of multiple terms, we can apply the derivative operation to each individual term and add and subtract their derivatives for that complete derivative. So in our next video, we will take a look at some examples working through these properties. Look forward to seeing you in the next video.